Today I'll be showing you different types of solutions that you're going to see when you are solving systems of equations by graphing. You learned how to find a solution when the two lines intersect. That's the assignment that we did yesterday. Now I'm going to show you some other possible scenarios where the lines will not intersect or they will be the same line, and what the solution or answer will be in those cases. So remember that a system of linear equations is two or more equations with the same variables, and they are graphed on the same coordinate plane. These are the different types of solutions you will see. One solution where these two lines intersect and the solution is xy. So the coordinates of the point where they intersect. So in this case, the solution is 1, 1. The next type of solution is parallel lines. Parallel lines never intersect. So there is no solution in this case. No solution. Okay, and then in the last example, you can see the equations look different. Y equals 3x minus 1 and 3x plus y equals negative 1. They are in fact the same line. One of the equations is written in slope-intercept form and the other is written in standard form, but when you graph them, it is the same line. We call this infinite solutions when they are the same line, because every point on those lines is a solution. Infinite solutions. So for today, we are going to be determining, does this system have one solution, no solution, or infinite solutions? So you're going to get your equations into slope-intercept form, y equals mx plus b. Identify the slope and the y-intercept, and graph both equations on the same graph. Identify the solution. Remember that one solution is the point where the lines intersect. And if there is one solution, I need you to tell me what the solution is. So let's look at this example. We have y equals x minus 3. So first let's graph this line. This is already in slope-intercept form. We're going to see that b is 3, negative 3, and we'll plot that here on the y-axis. That's my y-intercept. Then I have no number here in front of x. So remember, that's 1. So my slope is 1 or 1 over 1 if I want my rise over run. So this is going to go up and to the right. So 1 up, 1 to the right. I'll plot a few and then graph the line. Now remember, when you're doing systems, I recommend plotting several points using that slope so that you make sure that your line is perfectly straight, or you might have a hard time seeing where the lines truly intersect. Now let's look at 2x plus y equals 0. This equation is written in standard form, so you can either find the intercepts or convert it to slope-intercept form. So I'm going to convert it to slope-intercept. Subtract 2x, y equals negative 2x, and I don't need to write plus 0. So for this equation, since we didn't write plus 0, remember that's kind of invisible here, but that tells you that b is equal to 0. So my first point will be there. And my slope is negative 2. So m is negative 2 or negative 2 over 1, which means I'm going to go down 2 and 1 to the right. So starting at my intercept at 0, down 2 and 1 to the right. Down 2, 1 to the right, down 2, 1 to the right. Again, just do a few of them. Make sure your line is perfectly straight, and then graph the line. So you can see that these lines intersect. So there is one solution, and that one solution is 1, -2. Example 2. We have y equals x plus 5 and x minus y equals 2. So my first equation is already in slope-intercept form. B is +5, which is here on the y-axis. M, again, is just 1. So M is 1, or 1/1, which is up and right. So we'll up and right, up and right. I'll plot a few points here, and then I can graph the line. Next equation is x minus y equals 2. To convert this to slope-intercept form, I'm going to subtract x. -y equals -x plus 2. I'm going kind of quickly through these conversions because we did practice this in C Day 2. So if you can't remember that, go back to C Day 2 notes and review that. Divide by -1. Y equals x minus 2. So B is -2. Plot that on the y-axis. And M is 1. So rise over run is 1/1. So we see that these are parallel lines. They don't intersect on the graph, and they would never intersect going in either direction. So our solution is no solution. These will never intersect. All right, number 3, y equals -1/2 x plus 2 and x plus 2y equals 4. First equation is in slope-intercept form. B is 2. M is -1/2, so this is going to go down and to the right. So let's plot B at 2 on the y-axis, and the slope is down 1/2. Down 1/2. Okay. Next equation's in standard form. Let's do this one using intercepts. Remember, we have two options when we're graphing standard form. We can use intercepts or converting. The last couple of examples, we've converted the equation to slope-intercept, but let's try plotting intercepts this time. So I'm going to solve it two ways. I'm going to get rid of y first and then write x equals 4. That was easy. There was nothing to solve there. On the other side, I'm going to get rid of x and solve 2y equals 4. So divide by 2, y equals 2. So this point will be at 0, 2. This point will be at 4, 0. So 4, 0, and 0, 2 is actually going to give me the same line. Same line. That means there are infinite solutions. So every point is a solution to this system. All right, number 4, x minus 2y equals negative 6. This is in standard form, so let's solve this. Again, let's use intercepts. So I'm going to get rid of y first. X equals negative 6. Nothing to solve. Let's get rid of x. And then we have negative 2y equals negative 6. Divide by negative 2. Y equals positive 3. So I have a point at 0, 3, and a point at negative 6, 0. So negative 6, 0, and 0, 3. All right, and we have another equation in standard form, 3x plus 4y equals negative 8. So this time I'll convert this to slope-intercept form. So let's subtract 3x. 4y equals negative 3x minus 8. Divide by 4. And I get y equals negative 3 over 4x minus 2. So b is my y-intercept. That's going to be negative 2. So on my graph, plot negative 2. And the slope is negative 3 over 4. So this will be down 3 and 4 to the right. Down 3 and 4 to the right. Okay, so these lines do intersect, and the solution is negative 4, 1. Number 5. Both equations are in standard form again. So I will use intercept for the first equation, and then I'll convert to slope-intercept for the second one. Remember, that's your choice. What is your favorite method to use? What is the easiest one to use? That's what you should choose. So first I have 2x equals negative 12. And then I have negative 3y equals negative 12. So I would divide by 2 on this side. So x equals negative 6. So my point would be at negative 6, 0. And then for the y-intercept, divide by negative 3. Y equals positive 4. So 0, 4 is my y-intercept. Okay, and let's convert the second equation to slope-intercept form. Subtract 2x, 3y equals negative 2x plus 9. Divide by negative 3. So y equals positive 2 over 3x minus 3. So b is negative 3. So plot that, -3. And slope is +2/3. So that'll be 2 up and 3 to the right. So here we have parallel lines again. And when we have parallel lines, they will never intersect, so there is no solution. Today you have a paper practice assignment, so you will be indicating no solution, infinite solutions, or if there is a solution, you will tell me what that intersection point is.